the integral of e to the x over 3 plus 5e to the x dx. And then number 10 was very similar, the difference being that the top and the bottom were flipped. So we have 3 plus 5e to the x over e to the x, integral of dx dx. All right, now, when we look at these two, it turns out that the strategy for working with these two integrals, as you may have realized as you were working on this, the strategies are very different. In particular, if I look at these two integrals, the first one over here, because there's a plus sign in the denominator, means that there's not much algebra simplification that I can do with this one. And so this first one, as soon as I see two terms added together in the denominator, I know that I cannot split up this integral because there's nothing to split on the top. And so here I immediately want to start thinking about calculus, and I want to say, okay, well, what can I do? Well, one possibility is that I can let u be equal to 3 plus 5 e to the x, and then my derivative works out really nicely. I end up with 5e to the x, and so that's good because that's going to cancel my e to the x on the top. And so on number 9, this one ends up being relatively straightforward as a u substitution. So I can make my adjustments, the integral of e to the x over u and du over 5e to the x. My e to the x is canceled. I've got 1/5 the integral of 1 over u du. And now I can take my antiderivative. So number 9 is a pretty straightforward u substitution. We end up with 1/5 the natural log of u plus c. And then when I write this back in terms of my x, I have 1/5 the natural log of 3 plus 5e to the x plus c. Now, just as a comment on this particular one, technically anytime that you have the integral of 1 over u or 1 over x, the antiderivative of 1 over u is natural log of the absolute value of u. In this particular case, if you do not put in the absolute values, it doesn't really matter because everything inside the parentheses here is going to be positive. No matter what value of x you have, everything in there is positive. So the absolute values are not required. Now, if you did not put the absolute value bars in, I marked them in, but I certainly didn't take off any points because there's no difference between the absolute value of 3 plus 5e to the x and just plain 3 plus 5e to the x. Okay. All right, any questions about number 9? Okay. So in number 10, now, number 10, I kind of start to get excited. I'm like, ooh, Diane just put in the exact same problem, and now I don't have to think anymore because they're going to be just the same. And so if you start out on this one and look at it and say, okay, what can I do with this? Is there any algebra I can do to try and simplify? And the answer here is absolutely yes, because in our denominator is really an easy denominator. There's just one term. So I might try exploring this by trying to simplify first. And so if I do that, I end up with the integral of 3 over e to the x plus 5 e to the x over e to the x dx. And some things cancel, the e to the x's. And so I can write my integral as 3e to the negative x plus 5. And now I've got a new integral that's been simplified. Are there any questions about simplifying that? Okay, at this point, when I look at the e to the x, the plus 5, that part's easy. I can deal with that. I know what the antiderivative is of 5. But e to the negative x, I might do a u substitution here, and I might let u be equal to negative x, in which case du over dx is negative 1, and dx is equal to negative du. And so when I go back to rewrite this, I have the integral of 3e to the u plus 5. And then I have du, well, negative du, but I can just pull that negative right to the front. And so now, when I look at this, I have negative antiderivative of 3e to the u is 3e to the u. Antiderivative of 5 is 5u, and then I have a plus c on the end. And so then I turn this back into x's, so I have negative 3e to the negative x plus 5 times negative x, all plus c. And so this is a valid final answer, but if I want to clean up my negative signs, I'm certainly welcome to do so. And I have negative 3e to the negative x. I've got two negatives, so I've got plus 5x plus c. So the difference between these two is that on number 10, you want to make sure, hey, you know what, if I tried initially to put in a u substitution, it may or may not work. And so if I can simplify, I want to try to do that first. Number 4 and I think number 7 it was, maybe where there was a square root of x outside the parentheses and dividing by the square root of x, those you want to simplify first before you try and do anything else. In fact, you may not even need a u substitution. Now, I wanted to share with you on number 10 another option that does work. So if you start out with 3 plus 5e to the x over e to the x dx, and you start out and say, well, in number 9, it worked to let the denominator be equal to u. I'm going to do that in number 10 as well. So then my u is equal to e to the x. And I end up with du over dx is equal to e to the x. And I can solve for dx and get dx is equal to du over e to the x. And then when I come back over here, I end up with the integral of 3 plus 5 e to the x, oh, well, that's a u, over e to the x, which is a u, and then dx is du over e to the x. Okay, so at this point, I now have u's and x's, but nothing has canceled. So I immediately scratch my head and I want to start to cry a little bit and say, well, things are not canceling. So I start to maybe get clever and say, oh, well, that was really 5e to the x. But again, I cannot cancel because there's a plus sign on this top, so that would be illegal algebra for me to do any canceling. So I sit there and scratch my head a little bit more. And then I say, well, okay, I know that u is equal to e to the x, so I'm just going to replace both of these guys. And so I end up with the integral of 3 plus 5u over u times du over u. So everything is in terms of u's now, no more x's. But I still don't know what to do with this. And so at this point, I kind of scratch my head a little more. And then I ask myself, okay, can I simplify? And the answer is yes. We can write this as the integral of 3 plus 5u over u squared du. And now I can simplify this fraction by writing this as the integral of 3 over u squared plus 5u over u squared du. And I can clean these up so that they're no longer fractions and write this as 3u to the negative 2. One of my u's over here cancels, and so I'm left with 5 over u. All right. So now I've got two separate integrals here. I've got the 3u to the negative 2. I can even write this separately. 3 times the integral of u to the negative 2 du plus 5 times the integral of 1 over u du. And then that one, now this is actually pretty easy to integrate. I add 1 to the power and divide by that new power. So I've got 3e to the negative 1 over negative 1. And then I've got 5 times the natural log of the absolute value of u. And then I have a plus c on the end. So take a look at this. I mean, right now my answer is not looking at all like it's going to be this final answer over here. But we haven't done anything wrong. All right, so let's keep going with this. This negative 1, I can write this as negative 3 over u. The u to the minus 1 can go in the denominator. Plus, I've got 5 times the natural log of the absolute value of u plus c, and let's replace everything. We have negative 3 over e to the x plus 5 times the natural log of e to the x, and then a plus c. Okay, so this is a valid final answer. Compare this answer to the one over here. Are they the same?
Yeah.
Yep.
That's because the coefficient and the analogy is 1.
Okay, so here in this part right here, remember the rules of natural logs say that you can bring that power down in front. And so you can write this as 5x times the natural log of e, and by the way, natural log of e is 1. And so you're left with the 5x here. And then this beginning stuff, the e to the x was in the denominator, you can bump it up to the numerator and make it negative 3e to the negative x. And so these two answers are in fact the same, but if you solved it slightly differently, your final answer could look a little bit different. Okay. Any questions or comments about that? I thought this way was cool. I ran across it about halfway through the stack, and I was like, natural log, where the heck did that come from? And then I was working with it, and I was like, oh, that's cool. That works out well. So I wanted to share that. Okay. All right. So last time we talked about integration by parts, and I gave you some practice problems. Are there any questions on any of the practice problems of 6.1?